All right, chapter 8, we will be looking at solving trigonometric equations for the most part. Um, my computer was having issues this morning, so. Yeah. So in chapter 8, we're going to be looking at solving trigonometric equations. So it says in the top, there are two kinds of trigonometric equations. Identities, which will be studied more in chapter 9, are equations that are valid for all values of the variable for which the equation is defined, such as the Pythagorean identity that we talked about before, and knowing that cotangent equals 1 over tangent. In this chapter, conditional equations will be studied. So conditional equations are valid only for certain values of the variable, such as these equations listed here. So if a trigonometric equation is conditional, solutions are found by using techniques similar to those used to solve algebraic equations. So we're actually going to be using graphs to do it, which is what we're going to focus on today. And we're going to be looking at using algebra to solve equations also. And today we're going to look at, we're going to be doing the easiest part is using the graphs to find them. Right? Now if it's an obvious one to where we can use our unit circle, we will use that. If we need to use other methods, then we will. So solving basic trigonometric equations. All right, we're going to look at the method for solving them graphically right at the moment. All right. So some of them we can do, obviously we know how to do them with our unit circle, but we want to look at our calculator would use them too. So unless it says otherwise, you're always going to be using radians, okay? All right, so your calculator should be in radians unless it tells you that you're going to use degrees. If it tells you to use degrees, then you need to change your mode to degrees. But so always check your mode and make sure right now that you're in radians. Okay. And this first equation, they want us to solve the equation where tangent of x equals -1. So we'll go to our y equals. Put tangent in y1 and -1 in y2. Now, you should know what this answer is because -1 is for tangent is on the unit circle, right? Okay. So first of all, let's find our answer using unit circle, and then we'll go ahead and look at it graphically. So when does tangent equal -1 on your unit circle? Okay, so 3 pi over 4 and then plus pi n, right? Where n is an integer. Okay. All right, now that's according to our unit circle. If we look at it graphically then, and we hit zoom 7, make sure you zoom 7 when you're doing this, that we can find these intersection points also. So let's find the intersection point. So where do I go to do intersection point? Okay, second trace. All right, number 5. And we're going to find the intersection point here that is that would match our 3 pi over 4, right? Okay. So we're going to select our first curve and select my second curve, and then I'm going to scroll over to this one here. And I get the number 2.356. Okay. Now, anytime it's on your unit circle, okay, so if we have sine or cosine, and we're doing square root of 3 over 2, square root of 2 over 2, 1/2, okay, that's our unit circle. Or if we're doing tangent, that is square root of 3, square root of 3 over 3, or 1, then we're going to be using the unit circle. Any other values in that, then graphically, you can just find intersection points. And so this gives us 2.356. And so let's just check this other one just to see where that one is at. So let's see here. Take a picture of this. Okay, so that intersection is at 2.356. So if we go to the next one, and let's just check to make sure that is a difference of pi. And 5.497. So is 5.497 2.356 plus 2.14 or 3.14? Okay, all right. So that is a difference of pi. So we can say our answer is 3 pi over 4 plus pi n, where n is an integer. Okay, all right, so let's, now, that's the intersection method. There's another method called the intercept method. What's the intercept method? Okay, we want to know where it crosses, not the y-axis, but the x-axis, which means we have to have our equation equal to 0. So that means then the first thing we've got to do is subtract 0.33 from both sides. So we get the sine of x minus 0.33 equals 0. Now, what's the period for sine? What's period for sine? 2 pi. So we have to remember that then, since we're talking just the sine of 1x, okay, the value of b there is just 1, so that we're going to have all of our answers then are going to be plus 2 pi n. Okay. So let's go ahead and graph this one. So we've got the sine of x minus 0.33. And let's use it. We're going to do the intersection method. What we're trying to do, or the intercept method, what we're trying to do here is find the zeros. And when we get doing this, I really don't care which way you do it. Okay? If you would rather do the intersection method, that's fine. But I just want to go through both methods for you so you can use them. So we're doing number 2. So we want to find the zeros. So now when I'm looking for the zeros, that we're going to do, we'll always do the ones that are in the positive area between 0 and 2 pi. Now when we're studying, when we're doing the equations, all right, we'll look at it a little bit differently with the equations. Where'd it go? When we do actually doing it algebraically, we'll look at it a little bit differently when we're doing it algebraically. Okay, there we go. All right. So when we find these, we're trying to find this one here and that one there. And then the other two that are on here, these are both going to differ by 2 pi from those two that we find there in the purple. So let's find those two. So now when you're doing the zero finder, you're going to use left boundary, so you're going to be left of the 0, and then go to the right of the 0. So here it asks for left boundary, so I can hit enter there. And the right boundary of this 0, now remember we're going by pi over 2's here, okay? Because when we hit zoom 7, it goes by pi over 2. So the right side of this, what's the value of pi over 2? Do you remember? What's a numeric value of it? Well, let's see, pi is 3.14, right? So pi over 2 would be 1.57, okay? So you could, one of the things, what I'm getting to is the fact that you can just type in a number there like we do with trace. If you just want to go right to a y value and you know the x value, you can just click it. So I could put in 1.57 here, and I know that's to the right of that 0, and then I can hit enter for my guess, and it'll take me there. Okay. All right, so I have a 0 at 0.336. Okay, that's interesting. If it equals 0.33, it's 0.336 is one of the zeros. Okay. All right, and then we'll find the other one. All right, so we want to be left of it. So here I'm to the left of that 0, and then I can go to the right of it. So you can either use your arrow keys, or you can actually type in the values if you want. So here this 0 is at 2.805. So we have so my answer is going to be then that x equals 0.336 plus 2 pi n, and x equals 2.805 plus 2 pi n, where n is an integer. And then that'll always be the case unless it specifically tells you that we want to do it between pi, or between 0 and 2 pi, they might ask you that question. So if they put on here that they want us to find our answer from the interval from 0 to 2 pi, okay, what do the brackets mean? Remember, interval notation, the brackets mean it includes those numbers 0 and 2 pi. If it's parentheses, it does not include them. All right, so if they told us they wanted to know the answers between 0 and 2 pi, then we would just have 0.336 and 2.805. Okay? But since they're just asking us to solve this equation, there are infinite number of solutions, and you make sure you write down plus 2 pi n when you answer them. So here, when it asks us to solve equations graphically, you'll actually have two choices, the intersection method or the intercept method. Their suggestion is to write the equation in the form f of x equals 0, so you can do the intercept method. And part of the reason why the intercept method is better is because sometimes those intersection points are not very easy to see, but finding the zeros is usually really easy to see. All right. So the intercept method is much easier in some cases just because of finding zeros is easier than finding intersection points when the intersection points are not, you can't see them very well. So we want to determine the period of it, graph it over an interval and the length of the period. So the graph we make is only going to be the graph of the period then. So for sine and cosine, we would only graph from 0 to 2 pi. If it was tangent, we would graph it from 0 to pi. That way it eliminates all those extra values you don't need to pay attention to. Use your calculator zero finder, and for each x-intercept, all of the numbers, you get u plus kp. In other words, well, they're using k instead of n, so you can use either one, right? Where k is an integer, our solutions of the equation. All right, so let's look at number 3 here. All right, this one's a little bit more difficult. Now, you have to make sure that you type these into your calculator correctly when you're doing them, when you have squares and cubes and those types of things. So let's go ahead and put this in our y equals. So we have 4. That doesn't look right, does it? Okay. All right. So when you type it in, and if you do it this way, if you put the x in and then square it, okay, that is not squaring the x, that's squaring the whole thing. Okay, so that means cosine of x times cosine of x. Okay, so understand that. Plus the sine of x minus 2. My computer is having issues today. All right, so 4 cosine squared plus sine of x minus 2. And so we've got to figure out what the period is. Okay, so we graphed it. We have to figure out what the period is. So when I look at this graph, how long does it, when we're in Zoom 7 mode, okay, it's from negative 2 pi to 2 pi. Okay. So how long, or how many periods do you, or how many cycles do you see here graphed? Okay. How many cycles are graphed there? 2 of them, right? Okay, we can see that it starts up here in the left corner, goes down, up, and then it repeats that same pattern. So the period here is going to be 2 pi. Okay. So I want to change my window then to go from 0 to 2 pi. So all I'm seeing is one cycle of the graph. And now I need to find those zeros. How many zeros are there? Okay, there's 4 of them. So we're actually going to have to find all 4 of them because they don't, none of them differ by pi. So we're going to end up with the 4 answers in this question then. Right, so we've got to find all 4 of these answers. And then we'll say plus 2 pi n, or in the book they're using 2 pi k, and either one of them is fine. You can use. Okay, so we got these 4 zeros we got to find. So go ahead and find them. Okay, so I found 2 of them. So I found the first 2. Who's got the other 2? Or one of the other 2 then? And you can just write, where n is an integer, you can just write that at the end. You don't have to write that all 4 times. So, okay, where's the third one at? 3.776. Okay. All right. Morgan, you have the last one? 5.648. Okay, so make sure we got all those. All right, and then once again, this is where n is an integer. right, did you find all 4 of them? You did? Awesome. Okay. All right, so let's look at number 4 then. Now, let's talk about number 4 before you graph it. Let's talk about it for just a second. Because one of the things that it says here in these rules is it says to determine the period. So it says write it as f of x equals 0. Then it says determine the period. So let's write it, first of all, in that form. So we have the tangent of x plus 4 cosine of 2x equals 0. Now, what's the period for tangent? The period for tangent is pi, right? Okay. Well, what's the period for the cosine of 2x? Because what does that 2 do to the graph of cosine? Does it stretch it horizontally or compress it horizontally? Okay. It compresses it. So the period would be at pi also, wouldn't it? So the period for this problem, the period here is going to be pi. All right, so let's graph it completely first of all, and then we'll look at it in terms of that then. So I'm going to put, I did zoom 7 for a moment. So how many times does it repeat itself in that span from negative 2 pi to 2 pi? Okay, there's 4 times. You've got 3 complete ones that you can see, and then the ending on the left and the beginning on the right. Okay, so there's actually 4 of them there. So all we need then is to put our window from 0 to pi, so that all we see is just enough. So that means then that I'm going to find these zeros we have, which there are 3 of them here, and each one of them is going to be plus pi n, or plus pi k if you want to use the value of k. So we'll find those zeros. Let's see, we'll go from 0 to trace here. So in this case, you're going to have to use the trace. Use your arrow keys. Oops, too far. Go back. There we go. All right, so 0.974. All right, so you should have 3 answers here. 0.974, 1.28, and 2.459. And I wrote use k instead of n in this case, because I think that's what they use in the book. So that's the answers you'll see. But doesn't matter which variable you use. Okay? The variable you use doesn't matter as long as you say where variable is an integer when you're done. All right, any questions on them? Okay, let's do the last one then. Okay. Number 5 says some real-world applications of trigonometric equations require solutions to be expressed as angles in degree measure. The graphical solution procedure is the same, except you must set the mode of your calculator to degree. Okay? So in this case, we're using degrees. So we're going to type it in just like we have the other ones, but we're going to change our mode to degrees. So you have to pay attention to that when they change the mode on you, you have the correct mode. All right? And any answers you have in radians are probably going to be between 0 and 2 pi, and then your answers in degrees are going to be between 0 and 360. Okay? All right, so y equals 3 cosine of x squared minus 2 cosine of x minus 3. And then hit zoom 7 to start with, so you can figure out what the period is that you need to work with. Okay. And then we check to see how many times that happens, and divide it, cut it, and whatever. Okay. So what's the period here? Okay. We're in degrees now, right? Okay. So the period here is 360. Okay? Because if I said 2 pi and went from 0 to 2 pi, from 0 to 2 pi, here's what I would see graphically. Of course, we're only going to 6.28 degrees then, not 360 degrees, so it just shows that little straight line there. So I've got to go from 0 to 360. So our answers will be in degree now. Number 2. And, oh, this is good. It gives me 180 degrees there, so I can go from 90 to 180. Get my first answer of 136. And when we're using degrees here, you can go 1 decimal place is enough. All right, so 136.1 degrees is plenty. And so we have 136.1. And 223.9. So the big thing here is it's not overly difficult. It's just a matter of making sure that you're in the right mode, first of all. And like I said, you can use intersection method or the intercept method. The only thing is that the first thing you want to do is want to get it set equal to 0. So this one I just did here, I could use the intersection method. I'm just going to put 0 in my y2. So if you'd rather use intersection than the intercept or the 0 finder, you can do that also. Because now I'm just going to, now that I know it's equal to 0, I can use the intersection method. pick my first curve. My second curve is just going to be the line where y equals 0, and then find the answer. And I'll still find the same answer that way. Okay? So it's really up to you, but you want to, first of all, set it equal to 0. Second of all, get the period set. Okay? And then you can go from there. All right? Questions?